Hello everyone, I'm Dr. MANZOOR Ahmed, Assistant Professor of Mathematics, Department of Humanities and Sciences, Marri Laxman Reddy Institute of Technology and Management. As you know, we have already started Unit 3 of our Vedic Mathematics, and we have learned about YTKVY method and another method in our previous lectures. And today we are starting a new concept that is based on understanding easy square roots using Dwandwa Yoga, or we can say duplex method. So this is very important method as far as calculating the square root of numbers. So Dwandwa Yoga or duplex sutra is used to calculate the square roots of numbers. So how to calculate the duplex of any number? Let's first understand this concept. If we have to calculate the duplex of a single digit number, for example, we have a number 9 or a digit 9. So to calculate the duplex of this number, a single digit number, we can simply take the square of the given number. Here I have taken one example. If you have to calculate the duplex of a single digit number, which is 9 here in this case, you can simply take the square of the number, that is 9 square equals to 81. So the duplex of 9 in this case is 81. As you can see, d of a equals to a square, where a is any given number. So we have taken one example, that is duplex of 9, that is 9 square, which is 81. This is for a single digit number. What happens if we have a 2-digit number? So here you can clearly see from the screen that d of AB equals to 2 by formula into A into B. So the duplex of a 2-digit number, or when we have a 2-digit number, and to calculate the duplex of that 2-digit number, we can use the formula 2 into the first number and second number. We have taken the example as well. D of 1, 3, that is 13, that is a 2-digit number, that is equal to 2 by formula into 1 into 3, that is 3 into 1 into 2 equals to 6. So duplex of 13 is 6. Now if we have a 3-digit number, what to do in that case? That is D of ABC. Here you can clearly see from the screen that A, B, C, D are any 3 numbers. So when we have to calculate the duplex of a 3-digit number, which is ABC in general we are taking, that is equal to, we have to take the pair of the first number and the last number. Remember, here you can take the pair of A and C, then we have another pair of B. Here you can see by formula for a 2-digit number, as in the previous example, for the 2-digit number, the formula is given as 2 into A into C. Here we have A and C as a pair, the first digit and the last digit. So by the previous example, D of any duplex of any 2-digit number is 2 into first number into second number. So here in this 3-digit number, when we have to calculate the duplex of a 3-digit number, you can see we have to make a pair of the first digit as well as the last digit. So this is 2 into A into C by previous formula, plus by formula this is plus. Then we have a single digit number, and the duplex of single digit number, as you can see from the example first, that is calculated by taking the square of the number, and here the number is B, so plus B square. Once again I am repeating, if you have to calculate the duplex of a 3-digit number, you can make the pair of the first digit as well as the last digit and calculate. So this is a 2-digit number. Now you calculated by the previous example, that is 2 into A into C, by calculating the duplex of a 2-digit number, and then we are left with one number, that is B, and you know the duplex of a single digit number is calculated by taking its square plus B square. This is how we take the duplex of a 3-digit number. We have given one example on that. If 123 123 is a 3-digit number, we can calculate the duplex of this number by the formula as given here. 2 is by formula into first digit, that is 1, into third digit, that is 3, plus the middle digit, that is 2, plus 2 square, that is 2 square 4, plus 3 into 6, 6 plus 4 equals to 10. So the duplex of 123 is 10. So far we have calculated the duplex of a single digit number, a 2-digit number, and a 3-digit number. Now in this way we can calculate the duplex of a 4-digit number as well as a 5-digit number, and so on and so forth. Here we have a 4-digit number, that is ABCD. So these are 4-digit numbers. So by formula we can take the pair of the first digit as well as the last digit, and then we have B and C. So there are 2 pairs of 4 digits, we can say, that is A and D and B and C. Now we have AD as a pair and BC as a pair. Here clearly from these 2 pairs you can use these 2 formulas, that is 2 into A into D, that is 2AD, plus then we have BC, this is 2 into B into C, because for a 2-digit number or a pair of numbers we can calculate the duplex by the second formula for a 2-digit number. So clearly this is for a 4-digit number, we have 2 into A into D plus B into 2 into B into C. This is for a 4-digit number, and we can take an example of here D1 2 3 4, that is equal to, by this formula we can calculate 2 into 1 into 4 plus 2 into 2 into 3, because we have paired 1 with 4 and 2 with 3. So by formula this is for a 2-digit number 1 4, this is 2 into 1 into 4, which is 8, plus 2 into 2 into 3, which is 12. So this is equal to 20. So this way we can take the duplex of a 4-digit number. Now if a 5-digit number is given, or we can say that 6-digit number or 7-digit numbers are given, by this way we can calculate the duplex of the numbers. So for example, we have taken here as well a 5-digit number, which is A B C D E. In general we are taking this. So this is, we can take the pairs A and E, first and the last, then we have second pair B and D, then we are left with a single digit number. So by formula we can say that this is 2 into A into E for a pair of numbers, plus 2 into B into D, again a pair of numbers, then we are left with a single number, and the duplex of a single number is given by taking the square of the number, that is C square. By this way we can calculate the duplex of a 5-digit number. Students here should be well aware that these are the formulae for calculating the duplex of any number, whether it is a 2-digit number, 3-digit number, 4-digit number, so on and so forth. These are the duplexes of given numbers. So we have given some examples as well. So this is the concept of duplex, how we can calculate the duplex of a given number. This duplex in Vedic language is called as Dwandwa Yoga Sutra, or in English we can say that this is known as duplex method. So we will take some examples, and with the help of examples we will try to implement and we will try to understand this Dwandwa Yoga, or we can say as duplex sutra or duplex method. Let's take the first example. Let's move to the first example here. If we have to find the square root of 529. So students, you should be well aware that 529 is a 3-digit number, and we are here to find the square root of this number 529. As I have already told you, that first thing that you can do is you have to take this number in the form of pairs. So I have written over there. So at first we will arrange it in the form of pairs, but you should understand and you should remember here that we have to start from right to left. We will solve this example here. I will take a plain page. So this is how we can take, this is 500, 29, and we are here to calculate the square root of this number. First thing we can do is we have to take this number, or we have to arrange this number in the form of pairs starting from right to left. You should remember here that we have to start from right to left. So when we take this as a number, this is 29, this is 5, so this is first pair and this is second pair. This is a single digit number and this is a two digit number. Then you put separators like this and give a line, horizontal line, draw a horizontal line like this. This is the method that we can do. This is how we can calculate the square root of a three digit number or any number. Now, first thing we can do is we have arranged this number in the form of pairs. It is a three digit number. So first pair is starting from right to left. You should remember here that we have to start from right to left. So first pair here is 29 and second pair here is 5. You can do it for any number, whether it is a 2 digit, 3 digit or 5 digit or 10 digit number. You can arrange it. For example, let's take one more example. We have a number 5 6 7 4 2 3. So you can arrange this number in the form of pairs. For example, let us take 1 as well. So we have a number, this is a 7 digit number, 5 6 7 4 3 2 1, and we can arrange it in the form of pairs 3 1 4 2 6 7 and 5. So these are the separators, and draw a horizontal line like this. This way we can separate it. Remember one thing, after arranging it in the form of pairs, we can draw a separator and separate the first number, whether it is a single digit number, whether it is a two digit number, we can separate it. So this is one of the pairs, another pair, this is one more pair, and this is the last pair. This is a single digit number. So here in this case, we can take the same example, we can take the same form and we can use the same form. So after we have arranged this number in the form of pairs, draw a separator. So 5. Now what we do next is, the first thing first is you need to remember is, if it is a three digit number, you have to arrange it in the form of pairs. And here the first pair is 29 starting from right to left, and the second pair is a single digit number, that is 5. Now what we do next is, then we put separators on it, like here I have put the separators. This is 29, then 5, now 4. This method is very similar to vernacular method in finding the division of numbers or to divide the numbers. So if students remember the division method or vernacular method that other teachers are already giving lectures on, so this Dwandwa Yoga is very much similar to that vernacular method. So students, if you have not learned about vernacular method, you can go through the other lectures and you can learn about vernacular method. So vernacular method is very important in finding in the square root of numbers, or it is very much similar to this Dwandwa Yoga. Now in vernacular method we have the divisor, but here if you see, we have a number only 5 to 9. We don't have any divisors, we don't have any quotients, we don't have any remainders. So how to take the quotient or how to take the divisor first? If you see at the pair 5, which is a single digit number, you can take this number as 5, which lies in between the square of 3. It is less than the square of 3 and greater than the square of 2. So the first number is to be taken between the square of numbers, following it and preceding and following it. You see, if 5 is a number, it lies between the square of 2 and square of 3. So 5 is greater than 2 square and 5 is less than 3 square. If we take here 5 is greater than 3 square, it is not possible because it is 9, so 5 is not. So we can take this as 5, which is greater than the square of 2. Remember here you have to take the square of the number here and here. So 5 is greater than the square of 2 and less than the square of 3. So the first number that arises here, which is less than 5, that is 2. So 2 is the first quotient. So 2 is the first quotient, that is, which is the number whose square is less than the number 5. if you can see here clearly, 2 square, which is 4, is less than 5 and less than 3 square, which is 9 in this case. If you see, this 2 is the number and its square is less than the number 5, which is the given number here. So the first quotient that we take is 2. Now we are looking for the divisor. If you can see from our example, we don't have the value of either divisors or the quotient. To find the value of divisor, we separate the first pair from left and find its value between two numbers, square to be taken. So we have already taken the square of numbers and we have taken 5 in between them. So the next thing is, so 5 lies in between 2 square, that is 4, and 3 square, that is 5. So first quotient as given here is 2, which is the number less than 5 whose square is to be taken. Now the second thing is, we have to find the value of divisor. How can we find the value of divisor? We can find the value of divisor by taking the given number, which is 5, or you can clearly see from this table, which is 5, and you take the square of this number, that is 4. So this, or we can say that you have to multiply this number by 2. Whatever the first quotient is given here, you have to multiply that quotient by 2 and we get the first divisor. Remember one thing again, by taking the square of two numbers in between in which the first number lies, we have to multiply the first number by 2. This is by formula. Remember once again here, the first quotient derived here is 2. So you have to multiply this 2 by 2. So that is 2 into 2. If it is, for example, 4 here, then you have to multiply 2 into 4. 2 is by formula and 4 is the given quotient. If this is 6 here, for example, if this is 6 here, so you can 2 into 6. So the divisor is 12. But the first quotient here is 2. So you multiply this 2 by 2 by formula. You calculate, that is 2 into 2, which in this case is 4. So 2 into 2, that is 4. So the first divisor is 4. So the first divisor is 4, which I have already mentioned or clearly mentioned here. The divisor is 4. Now, how to find the remainder after that? We have find the quotient. We have find the divisor. Now we are left with finding the remainder. So remainder is 5 minus 4, that is equal to 1. So remainder in this case is 1. We have found the first quotient by taking a number 5, which is the first number here, and it lies between the square of two numbers. It is always to be taken between the square of two numbers less than it and greater than it. Here in this case, the number of which we are taking the square is 2. So 2 square is 4, that is less than 5. And the next number is 3, which is 3 square is 9. So 5 lies in between the square of 2 and square of 3. So 2 is the first quotient here. Now we are taking the first divisor, which is by multiplying this given number, this first quotient by 2, that is 2 into 2, that is 4. So this is remainder 1 R1. What is 2? This is Q1. So Q1 equals to 2, R1 equals to 4. Oh, sorry, this is divisor 1 equals to 4, divisor 1 equals to 4. Now we are left with R1. We have to find the value of R1. How can we find the value of R1? Simply by taking the difference of 5 and the divisor, that is 5 minus 4, which in this case is 1. So remainder 1 is there, quotient 1 is there, and we have divisor 1. So we will move on here. So we have now 5 minus 4, this is 1. So here is the remainder 1, and the number preceding it is 4, that is 5 minus 4, that is 1. So this remainder is to be taken here. That becomes 12. So if you remember the vernacular method, we follow the same procedure here. So we take this 1 to here, this remainder to here, this becomes 12. Now what is this 12 called? this 12 is called as gross dividend. Gross dividend. Now gross dividend is 12. How it becomes 12? When we find the first quotient, then we get the first divisor by multiplying this quotient by 2, which in this case is 2 into 2 equals to 4. Then from here we subtract this first number from this number. 5 minus 4, that is 1, which is remainder 1 equals to 1, and this remainder straight away goes here, and this becomes 12. And when we take this 12, this is called as gross dividend. After we find the gross dividend, we find net dividend. What is net dividend? Net dividend, I will discuss it later. So what is the next thing? The next thing is we are having gross dividend as 12. Here is the gross dividend, which is 12. So what we do next is we divide this gross dividend again by this divisor, which is 12 by 4. 12 by 4 equals to 3. What is 3? 3 here is, again you can see 3 is the quotient, and remainder is 0. When we divide 12 by 4, this 12 is the gross dividend. When we divide it by the divisor, so 12 by 4 equals to 3 is the quotient, and remainder equals to 0. So you put the quotient again here. This row stands for quotients. So here you see 3 is the quotient and remainder is 0. That will go here, and you put it as 0, 9. Again, now we have quotient 1 equals to 2, remainder 1 equals to 1, and divisor 1 equals to 4. Now quotient 2 equals to 3 and remainder 2 equals to 0. We move to this point. Again, remainder equals to 0. Now the number is 9, or we can say the gross dividend is 9 again. So we have to find again the gross dividend minus, we have to find the net dividend. In this case, now you see here we have a number 3, here we have the gross dividend 9, and we have the divisor 4 here. So when we find the gross dividend in this case is 9, again we have the gross dividend as gross dividend is 9, and when we find the net dividend, we simply subtract gross dividend, that is 9, minus duplex of this quotient. Here you can see in this compartment, we can see the quotient is, the number is 3. So we take the duplex of 3, which is 3 square, that is 9. So gross dividend is 9 minus 9, that is 9 minus 9 equals to 0. So remainder here is 0. Then we have the number as 0. Net dividend equals to 0. So net dividend equals to 0. You divide that by 4 again. So that is 0 by 4. The quotient is 0. The remainder is 0. So you take here 0. Now another 0 is to be taken here, but here the number ends, so that gets rejected. So this is again a quotient, but remember here why we have put 3.0 here. Remember students, here this is a single pair. So when we have a single pair here only one digit will arise. After that we have to put 0 and put the rest of the quotients. You can clearly see from this example, here in this compartment there is a single pair of number, that is 29. So here only one digit will appear. After that we have to put dot, and other numbers, other quotients will appear as 0. Now here in this case, why I have not taken the net dividend? Because here in this case, if you see, when we divide 12 by 4, that is quotient is 3 and remainder is 0. In this compartment we don't have any number here. So in this case the remainder gross dividend and the net dividend are same. In second case, the gross dividend equals to 9 and the net dividend equals to gross dividend minus duplex of the quotient, which is 3. So when we take duplex of 3, duplex of a single number equals to 3 square, number square, that is 9. So 9 minus 9 equals to 0. So you have to divide this net dividend by divisor, which is 0 by 4 equals to 0, that is quotient 0, remainder 0. Put quotient here and remainder goes to this compartment, but here the number ends, so we cannot put here 0. And so the square root of 529 is this. You count these numbers, that is 23.0, which is 23. So the square root of 529 is 23. I hope you have understood this example. Let's move to one more example, which is find the square root of 2025, which is a 4-digit number. Again, we have to arrange this number in the form of pairs, and clearly you can see this is a 4-digit number, so we have to arrange it in the form of pairs. So 2025 can be arranged like 20 and 25. Here I have arranged it, or we can take here, this is 25, the first pair, and this is 20, the second pair. Put the separators like this and draw a horizontal line this. Now we divide this number by the form of a separator. So then the separator is like, you take 20 and 25. Now we don't have any quotient here, we don't have any divisor here, we don't have any remainder here. So first thing we have to do, we have to take this 20 in the form of squares, which is 20 is greater than 4 square, that is 16, and less than 5 square, which is 25. Or this is 16 less than 20 less than 25, again as in the previous example. Now if you can see, this is 20, this is 25. Now we have taken the 20 in the form of numbers, and it is greater than the square of 4 and less than the square of 5. Always take the square of the numbers. Remember here, these are to be taken in the form of squares always. So what is the first quotient here? The number of which we have taken the square. So the first quotient here is 4. What is the remainder? And I have already mentioned that the remainder in the divisor in this case, the divisor in this case is the given quotient into 2, or 2 into 4, or 4 into 2, because multiplication is commutative, you can take. So that is 8. So the divisor here is 8. You can see clearly from here, 20, the divisor is 8 and the quotient is 4. So first quotient is 4, or we can say Q1, the divisor is 8, and we multiply this quotient by 4 and we get the divisor, which is 8. Now you see from here, you take this number and this number, but to find the value of the remainder, we can clearly see that we have to take the difference of these two numbers as we did in the previous example. So 20 minus 16, that is 4, that is the remainder. And what we do with the remainder is we take it to here. So this becomes the first gross dividend, that is 42. Firstly, we have to find the quotient, because in this case we don't have any quotient given, we don't have any divisors given, we don't have any remainders given. So how we calculate the quotient? We calculate the quotient, we take this number and we take it in between the squares of two numbers less than it and one greater than it. So the numbers are 4 square, that is 16, which is less than 20, and the another number is 5 square, 25, which is greater than 20. So this 4 is the quotient, the number less than 20 whose square is to be taken. So quotient is 4. Then we find the divisor. How we find the divisor? We multiply this number by 2 always. This is by formula what we calculate. So this is 2 into 4, which is always equal to 8. So 8 is the divisor. After finding the divisor as well as the quotient, how we find the remainder? We find the remainder by taking the square of the first number, that is 16. 16 is less than 20, so we take the difference of the given number, 20 minus 16, that is 4. 4 is the remainder. So what we do with the remainder then? We keep it here. So 42 becomes the first gross dividend. 42 equals to gross dividend. Then we calculate net dividend. What is the net dividend here in this case? The net dividend equals to gross dividend minus duplex of quotient. You see, here we don't have any number. In this compartment, the quotients arrive or they appear in this compartment. But you can clearly see there is no number in this number. So duplex of, we can see that is GD, gross divisor, dividend minus duplex of 0, which is 0. So GD minus 0 equals to GD. So here in first case, the gross dividend and the net dividend are equal, which is equal to 42. Again, after taking the gross dividend by taking the remainder here, this becomes 42. 42 is now called as gross dividend. After finding the gross dividend, after we get the value of gross dividend, which is 42 in this case, we are left with finding the value of net dividend. So net dividend is equals to net dividend equals to, that is gross dividend minus duplex of the number that appears here. But as you clearly see from this compartment, there is no number arriving here or appearing here. So we can take 42 minus 0, duplex of 0 is 0, that is 42. So in this case, in first case, the value of gross dividend and net dividend are equal, which is equal to 42. So now this is 42, which is net dividend as well as gross dividend. So what we do next is we are left with net dividend again. So we can say this is now net dividend. So again, net dividend is divided by this divisor, which is 8 5s 40, and 5 is the quotient and 2 is the remainder. Again, now here in this case, 42 is what? 42 is the gross dividend as well as the net dividend. In first case, there is no number here. So duplex of 0 equals to 0. So gross dividend equals to net dividend. Now we have another step. What we do is we divide this net dividend by 8 and then we take the quotient as well as remainder. So when we divide this net dividend by 8, 8 5s 40 and 2 is the remainder. Clearly we can see here quotient 2 equals to 5 and remainder 2 equals to 2. So gross dividend is 42, net dividend again is 42, because in this case, first case, there is no number here. So we are left with 0. So dividend, we can say duplex of 0 is 0. So net dividend equals to 42. When we divide 42 by 8, the quotient is 5 and remainder is 2. So you put 5 here. Now we have second quotient, that is 5, and we have remainder 2 which goes out there. This becomes 25. Now this is, what is this 25? You should remember again here, this 25 is again gross dividend, 25. Now when we have again a gross dividend, how to find the net dividend? The net dividend equals to 25 minus duplex of 5. Here now we have a number appearing there, that is 5. We have to find the duplex of 5. This is 25 minus, how to find the duplex of a single digit number? That is by taking the square of that number, which is 5 square 25. So that is gross dividend minus duplex of 5, which is again 25. So 25 minus 25 equals to 0. So what is 0 here? 0 is the net dividend. What is the next step? In first step, the gross dividend as well as net dividend were 42, the value was equal. In second case, the gross dividend is 25, but the value of net dividend equals to 0. So again we have the value of net dividend. So what we do next is, again we will divide this net dividend by the divisor. So net dividend in this case is 0. It is to be divided by the divisor, which is 0 by 4. So the quotient is 0 as well as the remainder is 0. 0 when divided by 4, the quotient is 0 as well as the remainder is 0. Again, the quotient 0 will be put here and the remainder 0 will go there, but here is a single pair, so that will not appear here. There is no number left now, so we will put 0 here, the quotient. But I have already told you, I have already mentioned in the previous example that this is a single digit number. This is a single pair of number. So here only one number will appear. After that we can put dot and the rest of the digits or the rest of the numbers. So this is 45.0. So what is the value in? So the answer of this question is we combine this value as 45.0 or 45. As you can clearly see that 2025 is the square root of the number 45. Again, I am repeating things. If you are unable to understand, we have to first arrange this number in the form of pairs. So 2025 can be paired as 25 and 20. Let me rub it first. Then we will start again. So 2025 can be paired in two pairs, which is 25 and 20. 25 and 20. So separate it and take one horizontal line. Now we don't have any quotient here, we don't have any remainder here, we don't have any divisor here. So firstly we have to take this number, which is 20. 20 lies in between the square of which numbers? It lies between the square of 5 and 4. It is greater than the square of 4 and less than the square of 5. This is the first thing you can do, students. You take here 20, this first pair, and you see 20 lies in between the square of 4 and 5. So what is the first quotient? That is the number which appears here. So the first quotient here can be taken as 4. After we have got the first quotient, we can multiply this quotient by 2 by formula, or 2 into 4 equals to 8. So the divisor is 8. Clearly you can take the divisor here. If I have already told you, if you understand or if you have learned about vernacular method, you can easily understand this. If you are unable to go through it, you can watch the other videos and you can learn about vernacular method. Then things will be easier for you to understand here. So we have got the first divisor, we have got the first dividend, we have got the first quotient. Now we can take the first remainder. How we can take the remainder? You see, you calculate the square of this. This is 16 less than 20 less than 25, and when we take the squares of these numbers, then you can take the subtraction of the number, given number 20, minus the first number, which is 16. So 4 is the first remainder. What we do with this remainder is we take it here. So this becomes 42. Again, this is to be taken in the form of pairs. So this becomes 42. So 42 is called as gross dividend. After we found the gross dividend, or we get the value of gross dividend, we have to calculate the net dividend. So gross dividend here is 42. Net dividend here can be taken as gross dividend minus duplex of given number. But if you see here in this compartment, there is, you can't see any number or nothing appears here, so you can take 0. So duplex of 0 is 0. Gross dividend is 42 minus 0 equals to 42. So in the first case, gross dividend and net dividend are equal and the value is equal to 42. So this is net dividend. Second thing is, now you divide this net dividend again by this number and take the quotient as well as the remainder. So 42 when divided by 8 gives us quotient as 5 and remainder as 2. Now here this compartment belongs to quotients. You can put the quotient 5 here, and the place of the remainder goes over here, and this becomes 25. Again 25 is what? 25 is again gross dividend. So gross dividend is 25. Now we have to calculate the value of net dividend, or we can say that this is equal to gross dividend minus duplex of this number, which is 5. So gross dividend is 25 minus duplex of 5. You easily remember that the duplex of a single digit number is to be taken by taking the square of the given number. So here we can say that duplex of 5 is 5 square, that is again 25. 25 minus 25 equals to 0. So what is 0? 0 is the value of net dividend. Again we have the value of net dividend, that is 0. Again we have to divide this net dividend by divisor, that is 0 by 8. So it gives quotient as 0 and remainder as 0. So remainder goes here, but the number ends, so no need to take the 0 here, but the quotient is placed here. Now this becomes 50. But students, remember here we have a single pair of numbers 25. So here only one quotient will lie in this compartment. So if there are more numbers following it, you have to take the dot, that becomes 5.0. So here the number has ended. So we calculate this quotient, that is 45.0, or we can say that 45.0 is equivalent or equal to 45. And in this way we can say that the square root of 2025 equals to 45, or the square of 45 equals to 2025. I hope after thoroughly explaining the thought about how to calculate the square root of any number using Dwandwa Yoga or Duplex Sutra, I hope you have understood the Dwandwa Yoga thoroughly through this example. And let's move to one more example, that is 51076. Now this is a 5-digit number. In our previous example that was a 4-digit number, and in this example that is a 5-digit number. And how to find the square root of 51076, which is a 5-digit number, use our Dwandwa Yoga or Duplex Sutra. Again I am telling you that if you don't understand this method, you have to watch the videos or on vernacular method of division, finding the division of numbers using vernacular method in our previous lectures. So here what we do first is we arrange the number in the form of pairs. Again you have to pair this number. Again you have to arrange this number in the form of pairs. So we will, I think the video is we are taking a lot of time, so we will go into the details quickly to find the value of, or the square root of the 5-digit number. So here you can see clearly that 51076 is the number. So form the pairs. This is 76, this is 10, and this is 5. This is a 5-digit number. Then put the separators, put a horizontal line, and separate this first pair from the rest of the pairs. Every time when you are calculating this, you have to separate whether this is a 2-digit number or a single-digit number. If it's an even number having 8 digits or 6 digits, then this will be a pair. Or if it is a 5-digit number, 7-digit number, 9-digit number, then this will be a single digit appearing here. So don't bother about this. So first thing is, this is a number 5. So we have to calculate this number in between the squares of numbers, that is 3 square, 2 square. That is the first quotient is, as we have already discussed in our previous example, that is 2. So how to find, this is quotient 1. How to find the divisor 1? That is by multiplying this quotient 1 by 2, that is 2 into 2 equals to 4. So here we have again divisor 4. Now how we can find the value of remainder 1? That is calculate the square. 4 less than 5 less than 3 less than 9, sorry. So 5 minus 4, that is 1. So this becomes 1. When this becomes 1, so what is this, Ilyan? This is again a gross dividend, that is 11. So what is the net dividend? After finding the gross dividend, we are left with finding the net dividend, that is gross dividend minus duplex of number. But here you can see there is no number appearing yet, or there has no number appeared yet. So you can take the duplex of 0, that is 11 minus 0 equals to 11. Here in this case, the net dividend and the gross dividend are equal. So we have find the net dividend is 11. After finding the net dividend, what we do? We again divide this net dividend by this divisor, that is 11 by 4. So when we divide 11 by 4, that is 2 is the quotient and 3 is the remainder. So you can clearly see here 2 is the quotient and 3 is the remainder. So quotient is to be put in this compartment. So we have our first quotient here in this compartment, that is 2. And what is the function of the remainder? That goes out there straight away there. So this becomes again a number which is 30. What is 30? 30 is again, we can say, a gross dividend. So here you can see that 30 is again a gross dividend. So we can take the net dividend. How we can find the net dividend after getting the value of gross dividend? You can simply take GD, gross dividend, minus duplex of the number appearing here, that is 2. So this is a single digit number. This is 20. 30 minus 4, this is equal to 26. So in this case here now, gross dividend is 30 and net dividend is 26. Again we have found the value of net dividend. What is the step ahead? We again divide this net dividend by this divisor. Again when we divide, so 6 is the quotient and 2 is the remainder. What is the function of the quotient? Quotient goes in this compartment following 2. And what is the function of the remainder? That will go here straight away. So we can see clearly from here, 26 goes here and 2 goes to this place, that becomes 27. Again we have 27. What is 27 here? Again it is a gross dividend, and we have to find the net dividend, that is 27 minus divisor of 20, duplex of 26. So again we can calculate here. This is a different thing, so I will again explain it. Now in this case, what is the gross dividend? Gross dividend is 27. So how can we calculate the value of net dividend? Net dividend is gross dividend, which is 27 minus duplex of 26. Now here, till now we had only a single digit number, but this time we are facing a 2-digit number. So to find the duplex of a 2-digit number is simply 2 into first number into second number, that is 2 into 2 4, that is 24. So 27 minus 24, that is equal to 3. So net dividend again is here 3. Now what we do is, we have net dividend equals to 3. So 3 is to be divided by 4 again. Net dividend is again divided by 4. That gives us quotient 0 and remainder 3. What will happen to this quotient? This will go there and this remainder will go here. So again we have 36 as the gross dividend. What is 36? 36 is again the gross dividend. This is to be continued unless and until the number ends. So gross dividend here again is 36. What is 36? It is again a gross dividend, and after getting the value of gross dividend, that is 36, we have to calculate the value of net dividend, which in this case is, you can see net dividend is 0, because we have to take net dividend here equals to 36 minus duplex of a 3-digit number, that is 260. That is 2 into 0 plus 6 square, as we have calculated as we have already told you about the duplex of finding the duplex of a 3-digit number, that is 2 into 2 into this number plus 6 square, that is 0 plus 36. So net dividend is 36 minus this value is 36 equals to 0. So again, this is net dividend divided by 0. We get the quotient as 0 and remainder as 0. You can put the remainder here, but the number has ended and the quotient 0 goes here. Now what? This is a 4-digit number, but here we have 2 pairs, 1 pair, second pair. I have already told you the number of pairs here will determine the number of quotient pairs here. So here after 2 digits we can put a dot, that becomes 26.00. So this is the answer of the question. The square root of 51076 equals to 226.00, or we can simply say that this is 226. The square of 226 is 51076, or the square root of 51076 is 226. I hope after taking these 3 examples you are well versed with Dwandwa Yoga, or the use of Dwandwa Yoga, or we can say simply as duplex method. This is how we calculate the square roots of numbers using this Dwandwa Yoga, which is a part of our curriculum. So in our next lecture we will start with finding the cube root of numbers using Yavadunam Sutra or Nihilam Sutra. In our curriculum only Yavadunam Sutra is defined there, but as Nihilam Sutra is again an integral part of our curriculum, so we will discuss both the sutras in our next lecture. Until goodbye and thank you.